Are you ready? Okay, now we're going to look at some very important things that are not in the book concerning the way in which the quantifiers interact with two truth functions, and or. So let's first look at how the universal quantifier interacts with and. So here's a sentence where that's going to be the property of sweet, and that'll be the property of bitter. So this sentence says everything is sweet and everything is bitter. Now here's another sentence. And this sentence says everything is sweet and bitter. So what I'm interested in are the inferential relations between 1 and 2. Does 2 follow from 1? Does 1 follow from 2? There's 4 possibilities for these inferential relations, only one of which is the correct one. Could be that 2 follows from 1 and 1 follows from 2. That's the first possibility. Or it could be that 2 doesn't follow from 1, but 1 does follow from 2. Or it could be that 2 does follow from 1, but 1 doesn't follow from 2. Or the fourth possibility is neither follows from each other. One of these is correct, the other 3 are incorrect. Here's the deal. Come to the board, only one initial should be underneath each one of these 4. Come to the board and put your initial under what you think is the correct answer. You can't lose. Only one initial underneath.
Might as well.
Okay, that's it for now. Only one. Only one. No more. We're only taking one person will get the free quiz. Okay, one of these 4 people will get the free quiz. So let us now see, but we're going to have 4 opportunities. There's no more no other possibilities.
There's 5 people.
Oh yeah, well he didn't know. So he gets erased.
That's the right one.
Okay, so here are the 4 possibilities. And let's see who's correct. So let's first look at whether 2 follows from 1. If that's true, if this is true, it rules that and that out. If this is false, this is ruled out and this is ruled out. Okay, so is it true that whenever everything is sweet and everything is bitter, is it logically true that everything is sweet and bitter?
Yes.
So if everything is sweet is true and everything is bitter, is it true that everything is sweet and bitter? Yeah. Yes. By conjunction, this and this gives you sweet and bitter. So that rules out that and that. So we are now left with 2 possibilities for the correct answer. So let's see if 1 follows from 2. If this is true, is this true? If everything is sweet and bitter, is everything sweet? Yes? Yes. If everything is sweet and bitter, is everything bitter?
Yes.
Yes. So by simplification, 1 follows from 2. So that rules out this one, leaving this as the correct answer. Okay. Now for the interaction of the wedge with the universal quantifier. And here too, there are 4 possibilities for the inferential relations. And once I finish with the last one, initial, what do you think is the correct answer? Yo, come on.
Yeah, that's fine. But that's fine.
Okay, only one initial per box.
I'm just gonna choose right now. Might as well.
Okay. So, we have to erase this. Okay. Now let's look at the possibilities. So the first thing is whether 4 follows from 3. Whenever 3 is true, is 4 true? So whenever you have everything is sweet or everything is bitter, is the following everything is sweet or bitter?
Professor, both the first and the last options are same.
What's that?
First and the last options are same.
Yeah.
Oh, I forgot to put in the squiggles. I was in such a hurry to get out of the way when people come running. Yeah, forgot to put the squiggles in. Okay, so we're looking at whether 4 follows from 3. So when everything is sweet or everything is bitter, is everything sweet or bitter? If everything is sweet, is everything sweet or bitter? By addition, true. If everything is bitter, is everything sweet or bitter? By addition, true. So 4 validly follows from 3, and thus that can't be right, and that can't be right. Leaving these 2 possibilities. So now we have to ask whether 3 follows from 4. If everything is sweet or bitter, is everything sweet? No. If everything is sweet or bitter, is everything bitter? No. So 3 does not follow from 4, thus ruling out this, and that's the correct answer.
That was me.
Okay. Good. Okay, now for the interaction of the two truth functions with the existential quantifier. So here we have, oh, sweet comes first. And here there are 5 possibilities, and I can see people are getting ready to move.
Can you go twice, Professor?
No.
Oh, that's pretty. You wanted to pause?
I'm about to fill in like 3 of them.
It says yes. I need a piece of chalk. I got one, thank you.
Yeah, do it.
Okay. Here are the four possibilities. So the first thing to ask is whether 6 follows from 5. So, if there is something that's sweet and there is something that's bitter, must there be something that is sweet and bitter? Who says yes? Who says no? And that's correct. If there's something sweet and there's something bitter, it doesn't follow that there is something that combines sweetness and bitterness. Doesn't follow. Here's a better example to think about this. Let this be snake. Let this be bat. Do there exist snakes? Yes or no? Yes or no?
Yes.
Do there exist bats?
Yes.
Do there exist snake bats? If this followed by logic, whenever you had a snake and whenever you had a bat, instantly would come into existence a snake bat. It would have to happen by logic. So this can't be right. 6 does not follow from 5, ruling out those two possibilities. I mean, sorry.
Oh, okay. There you go. Yeah, okay.
Crossed out the wrong ones.
No, I think I got it.
Okay, these are still up. These are still up. Okay, now, does 5 follow from 6? If there is something that's sweet and bitter, is there something that's sweet? Yes. And if there's something that's sweet and bitter, there is something that's bitter. True. So 5 follows from 6. And so this is the correct answer. 5 follows from 6, but 6 does not follow from 5. And this is true by simplification. If there is some object that has 2 properties, then there must be some object that has one of those 2, the same object. Is there a professor in this room who has a bandana and a shirt on? Yes. Therefore, there is a professor in this room who has a bandana. Okay. Now, 2 more possibilities.
Professor? We're not gonna reach that.
Okay, here we are.
Can I guess again?
Oh, come on. No, we're not doing this.
Let's get that last one.
It's the last one.
There's somebody else up there.
There's something there.
Yes.
Okay. And now let's see what the relations are between 7 and 8. So first we'll ask whether 8 follows from 7. If it doesn't, then that's ruled out and that's ruled out. So if whenever something is sweet or something is bitter, does it follow that there's something that's sweet or bitter? If there's something that's sweet, then there's definitely something that's sweet or bitter by addition. Or if there's something that's bitter, there's something that's sweet or bitter by addition. So 8 follows from 7, ruling out this and this. Now, does 7 follow from 8? Whenever there's something that's sweet or bitter, this is a tricky one. Whenever there's something that's sweet or bitter, does it follow there's something that's sweet or something that's bitter? If there's something that's sweet or bitter, then either there's something that's sweet or there's something that is bitter. Because we don't know what the property is this object has, whether it has one or both. But we do know there's got to be something sweet or there's got to be something bitter. Because there's something that's sweet or bitter. So 7 follows from 8, and this is the correct answer. And that is enough to learn about the interaction between quantifiers and truth functions tonight.